We're live, so welcome everyone. We're back here with another Infinite Layers. Today I'm joined by the Fluent team. So I'm joined not only by Dino and Dimitri, but we're going to be diving into Fluent and learning everything about what they're building. So before we go on, do you mind doing intros?
Totally. Good to be here. Big fan of the show. I'm Dino, one of the co-founders of Fluent and CEO of Fluent Labs. And Dimitri.
Yeah, my name is Dmitry. I'm co-founder of Fluent, and I'm still at Fluent.
Awesome. So I think I learned about Fluent maybe a year ago or so, ECC, or that was the first time we sat down and chatted about what you were working on. It was a lot earlier at the time. What is the like TLDR elevator pitch or the overview of what Fluent is, and then we're going to dive a lot deeper in after that.
Totally. So I can kick that off. So Fluent is the first blended execution network. Specifically, it's an Ethereum L2 that supports native composability between WASM, EVM, and SVM apps. So it's probably the most succinct like I could put it. And we can obviously dive into this concept of blended execution, which could, I guess, be a good like way to set this foundation, especially before we go into like a demo and kind of like show, what you could build with it. Would that be helpful?
Yeah, let's do that.
Okay. So I guess just to set the stage, I think it could be worth looking at like the status quo of like execution environments today. So the way we think about it is like basically all of the execution environments today are what we'd call single execution networks. And so what's a single execution network? So this could be a L1, L2, L3 blockchain. So the execution, we're specifically talking about the execution environment that supports basically one VM target, right? So very simple. And for the most part, this has been all like in the past few years, like EVM, right? And so there are clearly like good, people like to shit on the EVM from like a tech perspective, but there's clearly some like ecosystem attributes that are compelling around the EVM. Like it's built up a bunch of kind of network effects. Like there's a reason people are spinning up EVM L2s. We're not going to like knock that, right? So like, the tooling, the like actual apps you can use as primitives for what you want to build. Like, if you have a problem, you could type it into ChatGPT and stuff like that. The integrations, wallets, infra, all that kind of stuff. But over the past year, but there's clearly limits, right? Like you can only program in a certain number of environments, and there's kind of some inherent limits. And so over the past year, we've seen is a lot of momentum around alt VMs or next gen VMs or whatever you want to call them, such as like WASM VM, Move VM, SVM, obviously. And there's good reason for this. Like WASM, like why would you be interested in a WASM VM? Well, it supports all these different programming, like millions and millions of libraries and like Web 2 programming languages, which have obvious benefits. Move VM obviously has formal verification. SVM has been famous for parallelization, and they support Rust. So there's like valid like technical attributes of these like new VMs that people want to leverage, and you've seen that over the past year. And but at the same time, like there's like this trade-off in these what we'll call single execution networks. There's a very stark trade-off between like, okay, do I get like the ecosystem benefits of the EVM, or do I get the technical benefits of some of these novel VMs? And so people are forced to make this trade-off, and like what happens naturally is people try to get the best of both. Like that isn't that idea isn't like unique to us. Like people have been trying to do that, but we found like the implementation's pretty clunky, frankly. And so what people will typically do is I'd still call them like single execution environments, but what they're trying to do is take these like VMs, and there's different approaches. Some people try to like put one VM like on top of the other one. Some people try to like put both VMs kind of side to side. Like sometimes it's by two different development teams. Sometimes it's trying to integrate it into the same kind of blockchain network. But either way, like there's always going to be a limit in sort of like a clunkiness in like how those two things can interoperate. And so what we realized over the past half year is if you architect the thing from the execution environment from the ground up, you can actually do it in a way where it does support like binaries from all these different ecosystems, from all these different target VMs in a way that's like actually a good experience for developers. You don't have to have this end users. You don't have to have this like bridging experience between those two things that should be on the same network. You don't have to switch wallets. The contracts can call each other directly. And so you can have this environment that supports just smart contracts from all over the place in like a unified execution environment. And so that's what we call blended execution. And for Fluent specifically, as I mentioned before, we're focused on kind of WASM, EVM, and SVM apps, and the sandbox where all those can play nicely together, and where users can just keep a wallet and experience all of them in a unified way. So I'll stop there. Happy to field like any questions or pass it to Dimitri if you want to shed more light on like how the stuff works under the covers.
Sure, Dimitri, do you want to chime in?
Yeah. So let me expand Dina's thoughts regarding this. I can explain how it works under the hood and how did we find this approach. So the idea is quite simple. If you start to think from the bottom of the architecture of the system. So originally we started work on EZK proving system for WebAssembly. And so it's quite straightforward that everything you define, you can, everything you have in your blockchain, no matter how it's developed, how it's designed, what execution environment is used, what virtual machine is used, you can everything define using transition function, so-called transition function. If you develop a ZK application, for example, ZK circuits, you define the transition function using your circuits, using your proving scheme, and etc., and different commitment schemes. So what we found that if you can create like one language that you use to define the transition function, so technically you can put everything inside the transition function you have. And if you start to think about this more and more, you'll find that there is only the thing that we call instruction. So inside your environment, there is only instruction set. So we don't care about what is execution environment, what is state transition. We have only instructions, and we prove transitions from one instruction to another, and we modify the state of these registers, prove all these trees, and etc. And we found that using if you can correctly define the definition of your transition function, you can technically put any execution environment inside. And what's the main idea of the blended execution comparing to all other, for example, composability approaches? Because usually you have your state tree, and if you want to add more like multi-VM approach, or you want to add native composability with some other environment, you just create a special adapter or precompile using, for example, Solana, any language you want. And you can technically even implement it inside EVM. Why not? Nothing limits you here. Yes, not efficient, not super fast, but you can do this. So, the problem is that here you won't be able to have native composability between the different apps. You'll need to create special adapters that help you to transfer, for example, assets, some messages, and everything you want across different execution environments. But we found that we can just create only one tree, and create a special so-called simulated execution environment that maps all standards for these different execution environments into one state transition function, into one state tree. So we can create a representation of all Ethereum EEPs, of all Solana transaction standards, and we can execute everything on the same level. And you may ask quite simple question: what's the difference comparing to multi-VM approach to all the rest implementations? And the difference is that here you have so-called native composability. It means that there is no difference between Solana applications, WebAssembly applications, or EVM applications. All these applications are getting executed on the same level. So there is no virtual machine simulation inside. And if we talk about, if we imagine that the state that we have inside our transition function, it's a tree. And all, for example, addresses you have in Solana, EVM, no matter what scheme you use, even if you use different cryptography, for example, Solana is based on Edwards curve, and Ethereum is based on SEC256K1 curve. And all these addresses exist in the same tree. And you can calculate paths. I mean, you can calculate the binary path in this tree and do native interoperability between different applications. For example, if one application is developed using WebAssembly, it can invoke and interact Solana application. You can even transfer assets from one application to another application. You can send ERC20 token to Solana user using his Solana address. And the user with his Solana wallet can grab these tokens and spend them using this model. And yeah, so this is, so I tried not to go very deep and describe how it works. Is there any questions regarding this? Yes, I'm happy to answer.
Yeah, so it sounds like you essentially can build programs and be a developer on this platform in a variety of different languages, and they're all kind of like interoperable, all the different programs. Is that the general idea?
Yeah.
Got it. Yeah. So I think that's really interesting, mainly because like one of the things that I've talked about and I've really tried to understand how we can have approaches to fix this, or not to really to fix it, but to address the lack of developers in the Web3 space compared to other relative to other industries that are also software engineering. So I think that there was like numbers thrown around that are in the range of like 20 to 50,000 smart contract engineers that are actually employed doing this full time. Whereas if we look at under other industries that are also software, what other, I guess, programming platforms, it's closer to the tens of millions. So we're kind of like orders of magnitude away from that. And then you also look at the job discrepancies between the number of people that are hiring in this space and the amount of demand there is versus other areas where you're kind of starting to see a little bit of pullback on the hiring and the traditional software world. But in the blockchain space and Web3, the demand is still extremely high with a lot of high-paying jobs unfilled. So do you feel like something like this can be a lower barrier to entry for developers that are looking to kind of come into the space because they have more of a variety of languages that they can write and become productive with?
Yeah, I could jump in here and then Dimitri, I could pass the ball to you. So yes, definitely. Like we kind of look at there to be like two things that come to mind. Number one is for I'll say like the power users in the space, and so it's just like the ability to do things you couldn't do before with blended execution, and the ability to access audiences you couldn't access before with blended execution. So like with the former, I mean, you can probably intuit like the power of being able to like compose things across different types of like applications that weren't really like they couldn't benefit from that native composable experience before. So I won't spend too much time on it, but yeah, I think the accessibility to like the masses of developers is also gets tapped into more easily when you have something like a WASM base, right? Like the fact that kind of where the project actually like originally started, even just like surrounding WASM and these Web2 programming languages where you can basically take like millions and millions of libraries that already exist today and put them into the Web3 context and use them. And like that, you know, whether it's some kind of like algorithm or kind of advanced cryptography or whatever type of like precompile, like can actually be used as a differentiator to your app as well. And you know, these are things, I think there's some kind of like emergent benefits of like dipping into just like these millions and millions of like, you know, pre-built software pieces that you just kind of that people are familiar with and you kind of like stitch into your app. And yeah, of course, if they're in languages that you already understand, that's like definitely lowers the learning curve.
So what are some of the currents, what is supported right now? Where is Fluent in the life cycle of a software product? Is it on mainnet? Is it on testnet? Yeah, just curious like what the current state of Fluent is.
So yeah, the current status is we're still in the deep development stage. We're on developer preview right now version. So not full functionality is implemented. Most of things are still under development. We're finalizing in months, first working, fully working with, I mean, including native interoperability, all these native interactions, state transition function, etc. We're planning to finish it in months and share to the public, to everyone, to show most of important parts of the Fluent and start developers on working on integrations. Because we don't, of course, we're planning to onboard and attract developers from different Web3, Web2 areas, but also we're providing interfaces for developers to build on the edge between all these execution environments. So you can create a product. So actually, we're going to share an example of such application today and show how the native interaction can work and how we see this in our upcoming Fluent releases.
Got it. That sounds great. I guess that provides a lot more clarity. So I guess what can developers do today on Fluent? Can they build on like testnet or anything like that?
We have a public DevNet. It's still under development, and we're updating this on flight. We are going to share most of the documentation regarding this very soon, in a couple of weeks as well. Right now, they can develop and run EVM applications. So we have 100% of EVM compatibility, and they also can run WebAssembly applications. And we also have 100% of WebAssembly compatibility. We pass all official EVM and WebAssembly test suits. And right now, they can do interaction between these two apps and interact. And for example, they can develop an application that, as Dina had just mentioned, download some libraries, some official open source public libraries for Rust and compile and create an application and develop their own, for example, precompiled libraries and interact with these libraries from Ethereum, from EVM, for example, application, and it can improves the development experience because due to the number of limitations that exist today in EVM, developers are quite limited with what they can develop due to the limitation of the resources, of the gas, of the stack size, etc.
Before I have a bunch of more questions, but before I jump into those, do you want to touch on the presentation that you mentioned before, or just the demo that you wanted to kind of go over?
Yeah, we can go with the demonstration right now. Yeah, let me share my screen. So the presentation I want to show you today, let me start with a small diagram that describes the idea. So the application, it's a checkmate puzzle. So the idea of application is very simple. There is a checkmate board. You receive a puzzle, and you need to find the solution for this puzzle. It is developed using Rust language, and the wrapper for this application also developed by on Solidity. And by providing a valid solution for the puzzle, you receive ERC20 reward tokens. Here we can see the definition of the Rust application. Let's call it a prototype with a number of methods available. Inside the Rust contract, let's call it in Rust application, there are two methods. The first method verifies your move on the table for the checkmate, and the second verifies how valid is the entire field. And there is a Solidity application that provides functions to download the list of all puzzles. Also, you can create a puzzle if you want to with some rewards, and also you can provide a solution for the puzzle. And user can interact with Solidity application. So for user, it fully works and behaves like a regular Solidity application, but under the hood, it interacts Rust contract to calculate, to do all calculations regarding checkmate game. So here's the game. Here, the list of puzzles. User can open the puzzle, and here's the game. So the solution, the goal is to find the solution how to make a checkmate in this game. So you can see that it's quite easy. We just need to move here, and by doing this move, we make a checkmate combination. So the solution is correct, and we receive a transaction that this transaction is used to send our solution to the contract. And after on-chain verification, it emits some tokens to our account as a reward. So I have just confirmed the transaction. It's being mined in 1, 2, 3 seconds, maybe. It's still submitting. It's almost submitted. It's still mining. Here we are. So the puzzle is solved successfully, and we received 550 rewards on our wallet. And you can see that it's presented here in our token. Oh, by the way, I think it's incorrect token. Let me import new token. Here, you can see 550 tokens are presented on our wallet right now. So we can find another puzzle and try to solve this puzzle. So until you provide the correct solution, you cannot get the tokens for this. This is the game.
Nice. So where is that currently deployed, and what is it? What language did you write it in? And just I'm curious more details around what went into actually building that from the perspective of maybe a developer and the current platform and how it all works together.
Yeah, so it is deployed on our developer preview version of Fluent, and it's developed using Rust language with combinations of Solidity. For example, we took original ERC20 Solidity contract and deployed it on chain, and also and all corresponding logic regarding checkmate developed using Rust and deployed as a separate contract, as a library on chain.
Got it. Is this something that's open source for other people to test out and try out?
So most of SDKs are open sourced. Everything regarding the checkmate game, we're going to open source in days, right, with our technical specification, because we want to combine all these examples together and show and create the well-formed repository that describes how to interact with how to do interoperability between Rust and Solidity, between WebAssembly and EVM, technically, because you can use any language that is compatible with EVM. Like you can develop using EU language, but we're focusing right now on Rust and Solidity.
Got it. So I guess like if someone, you mentioned that it's EVM compatible, can someone kind of just port over their code and their development environment using Foundry or Hardhat or whatever and continue writing on Solidity and then expect their application to run normally?
Yes, exactly. 100% compatibility, no limitations.
And then in terms of Rust, like what does that developer experience look like?
So developer right now, so there are a lot of tricky stuff related to how to develop Rust applications, starting from API encoding, etc. So we're going to provide our guide for developers how to develop Rust applications and what, for example, API encoding scheme to use. We're suggesting developers to be Solidity API compatible. So to use Solidity standards just for simplicity for the development, because this is a well-known standard, everyone understands how to work with these standards, etc. And in the future, we're going to provide more and more encoding, decoding schemes for developers that are more efficient on our model. And for developer experience, for us developers, they just download their favorite IDE, their favorite Rust compiler, and include our SDK into the application and start to develop. So, and also there is no need to install any additional tool set for compiling applications for special magic binaries. No, just a regular compiler, specify WebAssembly target and compile to WebAssembly target. And you can upload your binary using regular, fully EVM compatible transaction deployment scheme. No additional modifications. So for developers, it's fully straightforward, and all guides are coming soon and will be available for developers in weeks.
Okay, interesting. That's very cool. So I guess like what does local testing look like then when you're not using Solidity, when you're writing Rust? and I'm sorry this is like a dumb question, but just trying to think about my day-to-day developer experience. I know that like if I'm building on the EVM, I can run a local Anvil node and hard hat, same thing. And then if I'm working with Solana, I can actually run a local environment. What would that look like locally if you're not writing Solidity?
If
Yeah,
not,
if I was writing Rust and wanting to test locally, what it would be like on the test network.
yeah, so you can run the DevNet locally. So we provide right now. Fluent runs on Rust Ethereum, and you can download the binaries and run it locally, and test the entire development on your computer. Also, all our libraries are fully STD compatible. It means that you can develop your application, for example, using your favorite IDE scheme with your debuggers. There is no need to install an additional toolset. So very, very common for developers, and all developers are familiar with these toolsets. And once you finish your testing, your developments, you just compile application and upload. So your development flow as a developer is not affected at all.
What about TypeScript? I think I know you all mentioned at some point TypeScript as a way to build contracts. What is the current state of that?
Yeah, so I want to be clear. What we call TypeScript, we mean assembly script.
Oh, assembly script. Okay, got
Yeah,
it.
so it's fully compatible with TypeScript, and
Right.
it's a language that is fully compatible with TypeScript, and you can use it to compile to WebAssembly. And right now, we provide SDKs only for the Rust language. So you can, as a developer, define our system bindings on TypeScript and develop your applications using TypeScript if you're familiar with how to define bindings, how to interact with them, and etc. There is no SDK for TypeScript right now because we're still under development, and we're modifying and changing SDK from time to time. So once we finalize first standards of our SDK development, we're ready to port it to other languages and provide availability for developers to use even C, C++, TypeScript, assembly script, and etc. Any language they want. Right now, it's still under development.
Got it. So I guess moving on beyond just the developer experience and more around the use cases and where it fits in the module ecosystem, and some of the things that went into actually building the protocol itself. Can you talk about, there's a lot of discussion right now around EVM or Ethereum, I guess, versus Solana and the Ethereum ecosystem. Obviously, this is not a one-to-one mapping between either Ethereum or Solana. It's a roll up, and it's also has its own like unique characteristics that differentiate it. So where does this fit in though in terms of the speed, performance, cost debate? And what types of applications do you see people building here? Because I know like you have this trade-off between often between security and performance, where if someone's having a high value per bit network, you might do more DeFi stuff. And if you have like a very low value per bit but high throughput, you might be focusing more on gaming or social or something like that. Just curious, like where you see Fluent fitting in.
Dimitri, you wanna start off with some of like the more like performance and architectural stuff, and then I'll jump in with some like apps and where we fit in the market.
Yeah. So regarding performance, we haven't, since when the development, we haven't finished any SDK benchmarks yet. So since we're SDK rollup, we're targeting to optimize state transition in terms of ZK. So we're optimizing ZK operations comparing to CPU computations, because most of things that are designed for CPU that is efficient on CPU is not efficient on ZK. And vice versa. Everything that is designed for ZK is not efficient for CPU. So it's very hard to find a trade-off here. What is the most important thing? Do you need to optimize CPU computations? Then you slow down proving process. and etc. So we have our so-called RWASM intermediate representation language. It's based on WebAssembly. It's almost 100% compatible with WebAssembly. The idea is that we use it to reduce number of circuits required for state transition and to simplify proving process. And what we do under the hood, I didn't highlight it before, but okay, I can reveal this. We translate everything we have into this intermediary representation language. And we do not do simulation of environments. We do ahead of time compilation. So once you deploy your application, we translate to our RWASM, to our reduced binary representation that is more efficient in terms of proving speed. It doesn't mean that we can achieve high performance in terms of regular CPU computations, but because we're targeting on ZK to optimize ZK proving process. But since all the solutions are scalable, you can still scale your solution and get more performance and do, for example, parallel execution of your transactions, because here in this model it's also possible.
Yeah. So the one thing I just want to touch on a couple of things on top of that. So there's, as far as just the modular ecosystem, right? So right now we're for the most part focused on our L2. I mean, it's hard enough to just bootstrap an L2 and get this tech off the ground and bootstrap the ecosystem, liquidity, all that stuff. So that's our focus. But I do, there is kind of, as I think we've talked about offline earlier, the framework as well called Fluent Base that people can use to basically build their own blended execution networks. And we envision all types of different types of trade-offs being made around around performance, actually around the VM targets that are supported, around performance, around kind of using different layers of the modular stack, around different types of sequencing, DA, stuff like this. And we want to make that framework as modular as possible. We've already integrated it obviously with EigenDA, and the way we envision this is many blended execution networks being built with Fluent Base. We don't see this, just to be really clear, we don't see this as kind of a consolidation back into one big fat roll up or one big fat L2, because we support all the apps, so just come and put everything on Fluent. Clearly things get clogged up at some point. And we're also just super bullish on what these blockchains and especially the roll up ecosystems can be used for. So yeah, I envision people using Fluent Base to make all types of different trade-offs. Maybe one would just optimize for support SVM and MoveVM apps, and just focus very heavily on parallelization, and then maybe they would use EigenDA for super high throughput DA, and that might be more kind of in line with, who knows, maybe that's very much some high performance DeFi thing, I don't know. And then another one might be a true ZK rollup, and they might only focus on maybe a different set of environments. And so we definitely see this fitting nicely into the modular vision as well. So it's just instead of 1 million single execution rollups, we would envision 1 million blended execution rollups.
Very interesting. So yeah, this is a lot different, I think, than what a lot of other teams that we've talked to that are just strictly building an L2 or a rollup. So yeah, where does exactly EigenDA fit in today?
Actually, Dimitri, you want to talk to that? There's both kind of the L2 part and then the framework part.
Yeah, so yes, I forgot to highlight one thing regarding Fluent Base framework and why it's important, because as I explained before, we're looking for the trade-off between proving and execution performance. And this is actually why we need the framework, the Fluent Base framework, because we use it to define a set of functions and runtimes that help developers to optimize their proving performance comparing to the execution performance. And it helps to find the balance between these. And we create special, a bit tricky interfaces for developers that they can use to interact with, for example, nested calls, to interact with context inputs and etc., and with different functions with Poseidon hashing, with keycheck functions, and it helps developers to optimize, because under the hood we take these low-level functions and we just replace them with circuits, and with them we prove them much faster compared to original execution. For example, we have our tree implementation that is based on sparse Merkle binary trees with Poseidon hashing. But every state transition for every chain requires supporting of journals, because you need to know the list of operations you roll back and remove in case of transaction failure. And it's very expensive for us to store these journals in memory. So we created our journal sparse Merkle binary trees. It's almost the same, but with one difference. It uses single-dimensional journals, and it stores list of all events and proves it using ZK. And we know in proving time, we know what operations are in this list, in this journal, are rolled back and which are not affected. And we use it to calculate and compute the new root just in time. It's different comparing if you take just REVM and execute REVM originally, because REVM creates these dumps, calculates all the states, calculates state difference, and then it compress all the state to the final state. And it's very, very, very expensive in terms of proving, because you need to prove all these memory transitions, all these memory copy operations that brings the giant overhead. So this is why we need the framework, because it helps us to move some operations from, for example, WebAssembly to ZK, and from ZK to WebAssembly, to find the most optimal solution, how to find the most optimal trade-off between performance and proving performance. Yes, and also regarding DA layers, yes, we can support, for example, we actually have support of EigenDA, and right now it's implemented as an additional layer that automatically scans all transaction inside Fluent. And for developers, if they want, for example, to develop something using Fluent base, nothing limits them to create layer 3. Nothing limits them to create layer 4. They can do whatever they want, because it's just a framework, and we develop our blockchain using our framework. So you can also develop your own blockchain using our framework, and you can settle it to layer 1, to layer 2, to Fluent directly. Why not? So we don't limit developers anyhow. All our solutions are open source. Take our framework, develop your blockchain, and etc. And of course, all integrations we have inside, including EigenDA, will go with this framework, and they can automatically enable this and decide how they want to settle their transactions in what layer, and etc.
So once everything is production ready and everything like that, would you compare this to something like the other rollup stacks like Arbitrum or Optimism as an alternative, or is this something different?
It's a bit tricky because you can use it as a stack for developing keychains, but I like to name this as a framework for transition functions. So because if you create a stack for like OP stack, etc., you automatically puts the definition of the framework. So it is used to design to layer 3, to layer 2, and etc. But it's not the thing you can do with Fluent base. You can do much more. You can develop your application. You can create your shared application. You can create smart contract. You can create a dedicated application. You can do outsourced computation. You can create a layer 2, a layer 3, of course, because it's still the language for state transition. And any transition you can imagine, you can define using Fluent base. And we're also going to, since we're based on this introduced the tree problem before. So it is possible because we have so-called circuit extensions, and developers, they can even accelerate their own computations using their own circuits. And they can include these circuits into our framework and create like so-called bindings. Let's call them system bindings, and they can interact with their own circuits using this. So if they have a specific task that is very optimal to be solved using ZK, they can just create a circuit extension and include this UI circuit extension and prove it, and then aggregate on our platform, for example. And we are also going to provide a lot of extensions for developers to be compatible with native Merkle-Patrusia trees, with more optimized ZK trees. If you want to go with EVM or one type, why not? So if you want, you can go. Also, we're going to provide more extensions to work with different hashing functions, and developers, they will be able to enable function they want and circuit they want to build their favorite circuit that combines all these circuits together, all these gadgets together, and that is the most optimal to prove for their specific tasks.
So do you see this fitting into any of the roll-up as a service products as well, as part of the configuration? Because I know it seems like you're decoupling, another piece of the stack essentially in some form or fashion, right? So do you think that it kind of would fit in those sorts of environments where, like, we have Caldera, Conduit, Alt Layer, Gelato, all and other ones as well, that are kind of offering like these different ways to piece together different roll-ups based on the use case and based on what the team wants. And do you see this maybe fitting into those stacks in the future?
Yeah, absolutely. So yes, as I mentioned, yes, you can create any configuration, and it perfectly fits into a rollup as a UI service model, because you can configure your rollup, you can configure your proving scheme, you can find the best optimizations balance, and run your own chain. And even there are different ways how you can prove it. You can create a transition proof using WebAssembly, and you can also, it's actually our second stage of development, but you'll be able also do an aggregation proof for your application. So you can outsource all computations to, for example, Provik Marketplace, and then just aggregate them on chain on our platform.
Well, we are getting close to being there on time. So I wanted to know, is there anything else that we haven't really touched on that either of you wanted to dive into before we wrap it up?
Actually, Dimitri, I was wondering if you want to talk a little bit about the rest of our eigenlayer kind of collaboration, right? So we also have kind of like the restaking component as well in our network.
Yep. Yes. Also, yes. Of course. Honestly, there are millions of things I want to explain. I want to talk, but it's impossible to fit it into one call, into one session. So yes, regarding eigenlayer, we are also going to enable on our public DevNet. It's actually already available. Technical docs are coming soon, and we're going to enable restaking model for our platform, and developers, they will be able to choose what deposit model they want to use. We're going to provide a native deposit withdrawal rollup flow. So if you want to go with amazing ZK-driven secureness, you can go. But if you want to get some additional yield from depositing funds on Fluent, you can go through restaking model. And using this model, you can deposit your Ethereum to the Fluent as an additional ERC20 token. And through an abstraction model, account abstraction, you can use both tokens, for example, to execute the transactions and to charge fees.
Yeah, you can think of it like a high yield bridge and then like a highest security bridge or something like that. But we definitely, like, at the core of this project is just optionality and making it like as flexible as possible for developers. So that was like a no-brainer for us.
Yeah, you seem to be like definitely a good fit for the whole modular category. It seems like a theme.
Yes, totally.
So I guess as we wrap it up, what are some of the timelines that you all want to kind of highlight for developers that are watching in terms of how they might start building and participating in the ecosystem over the next 6 to 12 months?
So our goal is developer preview is coming very soon, including all corresponding documentation. And public testnet is coming this fall.
Just to build on that real quick, I mean, in the meantime, right? Like we have onboarded a handful of devs just to kind of like kick the tires. And if anybody is kind of listening and interested, I mean, there's kind of like a pipeline of folks who we do want to get onboarded as soon as possible. But if you're interested in whether it's porting over a Solidity app because it's going to give you access to kind of like new types of like composable apps and experiences that you couldn't get on like another EVM chain, or you want to just build some crazy shit like the composable apps, right? If you just want to like push the boundaries of what's possible, and like we're still kind of like we're going to be building that in public and in real time, and we're going to be showing more examples like the chess puzzle game that he showed before. And like if you want to just like you grind your teeth on that, please reach out as well. We'll onboard you as soon as we can, and we'll work with you closely.
Amazing. Well, this has been really informative. I think this is a good opportunity for people to kind of learn more about all the different teams building in the EigenLayer ecosystem. So I appreciate your time. I know you all are extremely busy like everybody. So thanks for coming on today. And for everyone watching, thanks for checking this out. This will be on YouTube. If you chimed in too late, it'll be on YouTube in the next 48 or so hours. So that's it. Thanks for watching. We will see you next time.
It was a pleasure, man. Thanks.